look at a few more practice questions on Stokes theorem. So number 13, in this case, what we want to do is we want to verify that if the Stokes theorem holds true here. So that means we want to find out the surface integral of the curl, and also we want to look at the line integral as well. And then hopefully the answer will be the same. So let's look at number 13 here first. So what we want to do is that this is the vector field here, and S is a part of the paraboloid. Z is equal to x squared plus y squared, and lies below this one. So now, then what we want to do is first we want to look at this one from the line integral perspective. Based upon this relationship here, we are looking at the path x squared plus y squared equals 1. You see when z is equal to 1, and then z has to be equal to 1 as well. Then and then it has to be going counterclockwise, so that means, since it's oriented upwards, so that means r will be equal to a typical one, so all x equals cosine t, and then y equals sine t, and z is equal to 1. And then t goes from 0 through 2 pi. Now, then in this case, what we need to figure out is r prime. R prime becomes negative sine t, and then cosine t, and then 0. How about f? Was this one, but now, instead of y squared, now we're going to have sine square through the substitution. And then x will be now cosine t. And then z squared will still be equal to what? 1. So what we want to do is we want to get the line integral f dot dr. So basically that means I'm going to dot in f dot r prime and then dt. So then when I combine these two things together, what I'm end up getting is negative sine cube t plus cosine squared t dt. That goes from 0 through 2 pi. Now, so then let's try to look at this one together. How would you be able to integrate sine cube? In fact, I'm going to look at sine cube as 1 plus, or not plus, 1 minus cosine squared t, and then that will be equal to sine squared, and I have another sine. So in this case, what I can do is I can let u equals cosine t, then du becomes negative sine t dt. So then what I end up getting is for the first component, when I integrate this one, I'll end up getting, first one is u, 1, so it becomes u, which is cosine of t. And then this one becomes u cubed over 3, so that means minus cosine cube t over 3. That's what I end up getting. Now, how about the next one? Cosine of cosine squared t, we know that to be, this can be rewritten as is equal to 1/2 1 plus cosine of 2t. I can use that identity. So when I integrate this one, this becomes plus 1/2 t. And then the second one becomes plus 1/4 sine of 2t. That goes from 0 to 2 pi. But one thing about going from 0 to 2 pi you'll realize that cosine cube t or sine of 2t, all of them will become 0, whether you plug in 0 or 2 pi, because they're the same value. So this is equal to 0, 0, 0. Only thing that remains is this one. So what we end up getting is pi as our answer. Now, next. How about same question, but we're going to be looking at from curl, the surface integral perspective. Now we need to figure out the curl first. Now, y squared, x, and z squared. For the first component, the variables don't match, so therefore we're going to get 0. For the second component, still variables don't match, we're going to get 0. Third component, what we end up getting is, this one is 1, and then minus 2y. So that's my curl. Now, next thing which we need to realize is that what's the surface that which we are looking at? Even though we are looking at the paraboloid, if you remember the equation 3 from what we talked about earlier, instead of using the paraboloid, we can use the disk. X squared plus y squared is less than or equal to 1, where z is equal to 1. Then, if you're to use that one, what we're able to realize is the normal vector is simply k. So therefore, curl f dot ds is simply we gotta dot this one, and then dA. So when you do that, 1 minus 2y dA. But we get to realize that, hey, since it's circular, we can use the polar concept, where r goes from 0 to 1, and theta goes from 0 to 2 pi. So 1 minus 2 times r sine theta times r, and then we have dr d theta, and 0 to 1, 0 to 2 pi. When you integrate this one against r, then r becomes r squared over 2. Now, second, this one becomes simply minus r squared, so we get r squared sine theta, that goes from 0 to 1. Oh, actually, no, it's not r squared. Sorry about that. It was 2r squared already, so we get 2r cubed over 3. And then d theta. Then what we end up getting is when you plug in the 1 and 0, when you plug in 0, everything is a 0. But when you plug in 1, we get 0 through 2 pi, 1 minus 2/3 sine theta. Or rather 1/2 sine theta d theta. You know that sine theta over from 0 through 2 pi, this one would be equal to 0. And then 0 through 2 pi, 1/2 gets you simply pi. So therefore, either way, we will end up getting pi. That's how we can get this answer. Let's look at the next one. Number 15. So in case of number 15, we're going to do the same thing here. We're going to do the line integral and also curl to figure out the values together. Now, so as is a hemisphere, But looking at, so oriented in the direction of the positive y direction. So to figure out the y integral, the line integral, so imagine this is a hemisphere. But the thing is, y has to be greater than 0. So this is positive y. So I'm looking at something that goes up this way. So now, I'm not sure if you can see that or not, but so this one is on the xy, xz plane. Now, then from the positive direction, from looking from here, it has to go through the counterclockwise. And from here, instead of going to the this way, I have to go down this way. So from here, I have to go down first and then coming back up. So in other words, what I'm looking for here are x can be equal to cosine t. That's not bad at all. But y is equal to 0. And then z is instead of sine, but it's going to be what? Since I have to go down first, it's going to be negative sine t. That's the value of r. Now, then obviously what we're going to be getting is r prime, negative sine t, and then 0 negative cosine t. And we need to figure out the value of f. Y is equal to 0 here. Z, which was negative sine, and then x, which was cosine. So then f dot dr now becomes, when I dot these to 0, 0, I'm left with negative cosine square t dt, which goes from 0 to 2 pi. Now, so when you integrate this one, you remember how cosine squared t was equal to 1 plus cosine of 2t over 2. So if you remember this one, what we end up getting is we're going to get negative 1/2. I'm going to pull that out with a negative sign. I had 1, but 1 now becomes t. And then plus sine of 2t over 2. That goes from 0 to 2 pi. Of course, when it goes from 0 to 2 pi, this one becomes 0. What remains is negative pi. That's my final answer. Now, but the second approach is through the curl. So let's calculate the curl here. So here we get ijk y z x. I think y z x was the function. So now, when I try to find the curl, what would you end up getting? First component is, negative 1. How about the second component? Negative 1 again. Third component, negative 1. All three of them happen to be negative 1. Now, but what is the surface here? Because it's a sphere, R, I'm going to use the spherical coordinate system where the radius is equal to 1 because it was a unit sphere, I believe. Yes. So x now becomes sine phi cosine theta. Y becomes sine phi sine theta. and z becomes cosine phi. That's what I'm getting. So then, in this case, I need to figure out what would have happened if I were to get to cross them. So in other words, r sub theta, then what I end up getting is this one now becomes negative sine phi sine theta. Second one is sine phi, and then I get cosine theta, and then 0. And then phi, then what I'm going to end up getting is cosine phi cosine theta, and then second one becomes cosine phi sine theta, and then negative sine phi. So when I do cross, I'm just going to write down the results, and I think you should be able to get the same value. Here we get sine square phi cosine theta, and the y component is sine square phi sine theta. Lastly, sine phi cosine theta, cosine phi, both of them. So what we want to do is curl a surface integral of the curl f dot ds. Then in order for me to do that, I have to dot this one with this essentially. Then what do I end up getting? I'd be getting negative sine square phi cosine theta minus sine square. I think it's a sine square phi. I think I might have miswrote it here. Phi sine theta, and then minus sine phi cosine phi. And then that's basically what we end up having. So I can just put it as d theta d phi. Oops. 0 through pi in both cases, because we're only looking at y being positive. All right, so then first I need to take the integral against theta. So then what we end up getting is, so this one becomes negative sine square phi, and then sine theta, and then actually I can figure that out individually, but the easiest way, let me just let me just do that quickly. I think that might be easier for us to do. Imagine, because we're looking at the cosine theta, and this is simply a coefficient in this case, sine theta, you get to realize that in cosine graph from 0 to pi, they cancels away. So therefore, you get to realize the first one, this one becomes 0. And in case of sine graph, from 0 to pi, you get first loop here, and each component is 1, 1, so this area is 2. So what ends up happening is this one now becomes negative 2 sine square phi. And then here, I don't have any theta, I'm just going to multiply by pi. So what I'm getting is negative pi sine phi cosine phi. d phi. Now, the next thing that I want you to realize is that, okay, so in that case, what I can do is I can try to figure out the integral for this one. In case of sine square, we know that to be 1 minus cosine 2 phi over 2. So with the negative sign, what I'm going to do is I'm going to rewrite that as, I'm going to factor out 1/2 with the negative sign. And then I'll cancel out the what's called 2. So what I end up getting is simply negative 1. And then 1 now becomes phi. And then cosine of 2 phi becomes minus sine of 2 phi over 2. That's what I'm getting. And then this one, I'm going to look at this one as this is half of the double angle formula for sine. So in fact, sine of 2 phi over 2, 1/2, that's what this one is. So when I take the integral of this one, then what I end up getting is negative, actually it becomes positive, pi over 2, and then cosine of 2 phi over 2. That goes from 0 through pi. When I go from 0 through pi, because of these two as a coefficient, same thing is going from 0 through 2 pi, where these two things will cancel away. And our answer is negative pi. So either when I take the surface integral or line integral, you can see that my answers were the same. Hence, we're verifying the Stokes theorem. All right, let's look at number 17. Number 17, the particle moves along the line segment from the origin to, so imagine if I were to try to sketch this one. Origin is right over here. 1, 0, 0 would have been right over here. And then 1, 2, comma 1, so then it would have been somewhere around here. Let's say this is 2 and then going up by 1. And 0, 2, and 1. So that means what I end up getting is I'm getting a rectangle Now, they want us to find the work done that goes along this path. But using the Stokes theorem, what I can do is I can just find the curl about the surface here. How can I do that? Then, first I need to figure out the equation of this plane. Because you can see that, I'm not sure if you can see, but this is kind of slanted plane that cuts through this line right over here. So x is independent, goes from 0 through 1, x goes from 0 through 1. And the z is in fact half of y. Because if you think about it, this one is the projection of z equals half of y from yz plane and extend it over in x direction from 0 through 1. Now, then in this case, let's talk about the curl. What's the curl? Z squared, 2xy, 4y squared. So then, first x component here is 8y, and then this one I don't have anything, so I only have 8y. How about the second component? Here I have 2z, and then, yeah, that's it, 2z, third component is 2y. It's simply 2y, I guess. So that's the curl. And then in this case, since function is z in terms of x and y, even though I don't see x, what I can do is I realize that r sub x cross r sub y, earlier we realized that this one was equal to negative of partial against x, which would be equal to 0, and negative of partial against y, which would be equal to negative 1/2, and then 1. So that's basically what we have. And we want to dot these two things together. Then what do we end up getting? We're going to get first one is 0, second one is negative z, and then plus 2y. Now, but z is in fact half of y, so what we end up getting is negative y plus 2y dA. In other words, I'm getting y. So we could have dx dy. X goes from 0 to 1, and then y goes from 0 to 2. In this case, y goes from 0 to 2, as you can see over here, while z is going from 0 to this one. So that's the boundaries. So then what do we end up getting? In this case, actually, I think I might have miscalculated here. 1/2, then it becomes 3 over 2. So what we end up getting, in terms of x, is just 1, same thing. So we get 0 through 2, 3 over 2, y dy, then 3 over 4 y squared. Goes from 0 through 2, we get 3 as our answer. So with that one, we found out the value of work done, which was equal to 3. All right, so with that one, I'm going to close up. I'll see you later.